we have done adding, subtracting, and multiplying was yesterday. Okay. Let's look at dividing. So the nice thing is that the algorithm is very similar to what you did in the 4th grade. As long as we can do that, we can apply it to polynomials, no problem. Okay, homework is also right up here. Let's take a minute to remember. Write that down. Can you remember how to do long division? Okay, just ring a bell. So how many times? 72 times what equals 3,756? Is another way of looking at it. Alright, so 72 does not go into 3, does not go into 37, so you go one more. Say, how many times does 72 go into 375? What's that?
4 times.
About 4 times? 5 times?
No,
Just kidding. We can estimate and
yeah, it's 5.
try with 70. It's like, 70 times 5 is 350, so that makes about sense, about 5. Right, 72 times 5 would be 360. And here's the algorithm. Then we subtracted. So from 360 to 375, that's 15 difference. And then we brought down this next one. Look familiar? Okay. And then that's the process, and we might have to do several iterations, which means we just repeat that again and again and again. Different numbers, same exact step. So 72 into 156. Okay, so again, estimate with 70. 70 times 2 would be 140. So, yeah, we said 2 times 72 would be 144. Subtract those two. That'd be 6 plus 6 would be 12. And then we called this a remainder of 12, which is the same thing as saying there's 12 out of 72 left over. So that means 52 and 12 seconds times 72 is what will equal 3,756. So we'll do the same thing with polynomials. So just have x's and x squareds and things like that. Higher powers as well. Okay. So let's get to the good stuff right away. Yeah. Get to the good stuff right away. Now, at first, we're going to start on some basic ones. And remember, our question here is saying x minus 3 times what is x squared plus 7x minus 30? Can you already get that answer without doing all this long division stuff? Okay. Think about, what does this factor to? X what? What multiplies to negative 30 and adds to 7?
Negative 3.
Negative 3 and 10. So it stands to make sense if I wrote this using a fraction bar instead of a division sign. If I wrote this like this, okay, what would the answer be? Yeah, let's just cancel out and you get x plus 10. So what's the answer to this whole problem? It's x plus 10. That's what x squared plus 7x minus 30 divided by x minus 3 equals. It's x plus 10. Okay? Super easy. How would I show this same thing using the long division? Let's look at that. Alright. Using the long division algorithm. Okay. We're going to do all this. We're going to expect to get this answer. Same problem, we're doing it 2 different ways. Here's the kick, of course, you're not always going to know how to factor this, so you're not going to be able to just cancel out and say, oh, the answer is this. So that's what's going on here. So, well, why are we doing this long division if we can get the answer without it? Well, we're not always going to be able just to say it's, factor is so simple. What if this was like x to the fifth minus 4x to the fourth and something a little complicated? We're out of luck. We have to do it this way. But some of them we can have an option. So we're really just going to look at, if you remember, we looked just here. Okay. This is like the 72. The minus 3 is going to go along for the ride, though. So how many times does x go into x squared? There it goes. Cool. Yeah. In other words, what times x is x squared? Say x. Right. And we do a distributive property. X times x is x squared. X times negative 3 is negative 3x. Okay. And then what do we have to do here? What's the next step? Subtract. Although we have to subtract so both of these, so it's like a distributive property problem. So x squared minus x squared is the 0. That's good. But be careful here. 7 minus negative 3. 7 minus negative 3. 10x. And I would say 90% of the time, if there is a mistake on these problems, it's right there. It's distributive of negative. Distribute that negative. And then repeat. One iteration, let's do it one more time. And as you can see, okay, how many times does x go into 10x? Or in other words, what times x is 10x? We get a positive 10. So we can see our answer is exactly what we expected it to be, and we know we're done. Subtract both of those. 0, 0. Negative 30 minus a negative 30 is 0. So basically, after all this work, all we're saying is x plus 10 times x minus 3 equals x squared plus 7x minus 30. Because multiplication and division are just inverses of each other. The backwards of multiplication is division and vice versa. Let's have you guys give it a go. You can do either one. Well, do both. Do the long division for sure. Okay, you can check with mine here. Let's see here. What times x is x squared? It's x. Distribute. X squared minus x. Okay. But don't forget, it's subtraction. So we get 0 here. Negative 13 minus negative x. Negative 12. Make sure you got negative 12 there. Negative 13 minus negative 1. You need to put the 1 in there, you can. And then we'll bring it down. And repeat. So, good to know that if you get stuck, this is where you always look. After you multiply, check to make check that row to see if the subtraction is correct. Some people just actually like to switch the signs right away, so they'll do this. They'll say, well, if it's negative 12 here, they'll say it's negative 12. And then when they multiply, negative 12 times x, they'll change it to positive. They'll do negative 12 times negative 1 is positive 12. They'll change it to negative. They'll just change the sign. So they'll do the multiplying and the distributive property all together so they don't forget about it. And that way you don't have to have much worries. And you can see here, it'll be adding it up and it'll be 0 now. So if you like that, that's fine as well. And again, what does this prove? Okay, it just means that x squared minus 13x plus 12 divided by x minus 1 is the same as, well, this is x minus 1 times our answer, x minus 12. All divided by x minus 1, so of course our answer was x minus 12. So let's kick this up now to something above a quadratic where we're not going to be able to do this. This is just a luxury in the beginning. Alright. Okay. Now we got to the third power. Now, do we know how to factor this? Can we just break that up easily? Probably not. So here's where we pretty much required to do the full long division with no way of checking. There we go. Now, watch me here. Since we don't have any a squareds or a's in here, I'm going to put in some zeros for that. Because we're going to get them when we do all this multiplying from the top here. We're going to get a lot of a squareds and a's. It's just nice to have a place filler. Okay. There we go. So this actually has something to it. When I say set up long division, not necessarily just write it down exactly, but maybe have to put in some fillers if there's any degrees missing. Alright, good. Now go ahead and start. Alright, so what times a is a to the third? A squared. A squared times a to the third, change the sign. A squared times negative 4, change the sign. You can see right here, why did we want to have these zeros in here? Because now it will line up just fine. Okay, add them up. And bring down the 0. Just bring it down just like anything else, any other number. And repeat. So what times a is 4a to the second? Just 4a. Okay. Multiply, change the sign. Multiply, change the sign. And then do the third iteration all. So we have, let's see, plus 16, looks like. Multiply, change the sign, negative. And multiply, change the sign, positive. You will have some remainders, and if you do, that's okay. So what does all this mean? A to the third minus 64. Okay. Divided by a minus 4. Turns out, we didn't know this, but this actually factors to a minus 4 times whatever our answer is. A squared plus 4a. A squared plus 4a plus 16, all divided by a minus 4. How do I know a minus 4 is on the top? It's because there's no remainder. I know it goes into it evenly. So these cancel out, and our final answer was this. There we go. So filler numbers when necessary. And right here. You want the variables to be going down by 1. So a to the third, a to the second, a to the first, a to the 0. Why don't you guys give it a go? Put in the fillers. Do all the good stuff. Everything. So, put in 0b to the second plus 0b plus 27. Focus only on the b's. So what times b is b to the third? It's b to the second. Let's do some multiplication and change the sign. B to the second times b is b to the third. Change the sign. B to the second times 3 is 3b to the second. Change the sign. Add them up. There you go. And repeat. What times b is negative b to the negative 3b to the second? Multiply, change the sign. Multiply, change the sign. So, yeah, these are the keys right here. Making sure, well, not there, right here. Making sure that's correct. And making sure this comes out correct. 9b. Finish it up. Plus 9. Negative 9b and negative 27 gives us the 0, so it goes even. I think that's about it. So I gave you a few that are a little bit simpler. They don't have any gaps as far as the variables. It goes from x squared to x to the 1 and so on. We didn't have to fill in anything. Gave you some that do have gaps, so we had to fill in with the zeros as needed. And, a little bit of your homework from last night. You want to look at a few of those right now. Look at those evens that you didn't get to check in the back of the book. They weren't there. Were these the same problems? Look a little different.